My name's Tim Mills, the Technical Support Manager at Contacta. In this video, I'm going to be showing you how to carry out a survey in preparation for the installation of a large area loop system. Prior to a large area loop installation, a site survey should be carried out to determine if the venue is suitable for a large area loop system. Part of the survey will include checking for electromagnetic background noise. To do this, we would use a field strength meter. I have one here in my hand, and what we're looking for is a very low level of background noise as noted here. If these values are above minus 32 dB, there's going to be a strong magnetic field that could interfere with the hearing aid. What you should do is walk around the area that is going to be covered by the induction loop system and check for electromagnetic background noise using this field strength meter. This is simply done by walking around the room and making a note of any high levels of electromagnetic noise. Now we've done a background noise check, we can move on to checking for metal loss. The way we do that is to lay a test loop around the perimeter of the room and connect it to a loop driver and drive some current through it and take some readings. The first thing we need to do is connect the loop that you've just laid to the output of the loop driver, like thus. The next thing we'll need is a tone signal generator, and for this we're going to be using our TSG1. It has various frequency outputs on it, and you can select them by pressing the button to switch it on, and you'll see that there's a red light showing the corresponding frequency output. Just by pressing the button once, you can move through the frequencies to your chosen frequency that you're going to use. So before we start, we switch it off and then we connect it to the line input on the back of the loop driver. And finally, we connect the power to the loop driver. Once the power is connected, we have to wait for it to do its boot up self-test. And the loop driver said there that it was loop good. So we now have a good connected loop and we're ready to carry out the tests. We've made our final connections to the loop driver. We've got the TSG connected, we've got the power connected, and the loop driver's powered up and ready to go. The next step is to drive some current into the loop driver and carry out our metal loss tests. The first thing we need to do is switch on the signal generator, and we set it to the 1 kHz setting. The next step is to adjust the loop driver to drive 2.5 amps approximately into the loop. To do this, press the button to select, and on the top bars, adjust to approximately 5 bars. Now we can check to see what our loop output is, and this will vary depending on the size of the loop, but we have a 2.3 amps. Set the field strength meter up into the middle of the perimeter loop at the listening plane height. So the listening plane height for myself sitting down is 1.2 meters because that's the height my ear is. We're going to take some readings on the field strength meter. The first thing we do is we set the TSG to the 1000 Hertz sine wave setting, and we will then look at our field strength meter and make sure we have it on the 1000 Hertz third octave setting. Now I take a reading at 1000 Hertz, and the reading I have is minus 6.2 dBs. I now need to change the tone signal generator to the 5000 Hertz setting. So likewise, I need to change the field strength meter to the 5000 Hertz setting, and I do this by pressing the select button until I see 5000 Hertz on the display. And now I take a reading at 5000 Hertz. And the reading is minus 6.4 dB. The next step is to change the tone signal generator to 100 Hertz, and likewise the field strength meter to 100 Hertz. And the reading is minus 5.7 dB. We now have all the information we need to determine the metal loss in this room. Now that we've taken our readings, we can determine if there's any metal loss in this building. The IEC standard states that frequency response of a loop system should be plus or minus 3 dBs of the 1000 Hertz sine wave reading. In our case, we have very, very little metal loss because the readings are showing that they're very, very close to the 1000 Hz reading. For instance, the 1000 Hz is minus 6.2 dBs, the 100 Hz is minus 5.7 dBs, and the 5000 Hz reading is minus 6.4 dBs. Okay, the final step of the survey is to discuss with the customer the installation method for where the loop cable is going to go, where we're going to install the main loop equipment such as a loop driver, a radio mic receiver, any other sound sources that may be in the room. The customer may have an audio rack that we can install our equipment into. So we discuss all these things with the customer to make sure that they're happy that they're getting what they want.